Hello and welcome to the channel. In this video I'm going to be giving a beginner's guide to an AI agent that I wrote, or Claude Code wrote to be more precise. It's called Jira Agent, and this slide deck we're going to be tracing the data path or the execution path from a typed sentence, natural language request, to interacting with Jira, getting Jira to do what it is we've requested it to do. The slide deck's called from sentence to side effect, so from a natural language request to Jira actually being updated. So if you're new to AI agents, you've never coded one before, or you want to see how a simple AI agent is coded and how it's architected, that's what we'll be covering in this video. So let's get going. Actually, before we move on to the main content of the video, I will take a quick moment just to talk about how I created this slide deck. So this is a HTML slide deck. It's not PowerPoint. It was created by Claude Code. I used a plugin called front end slides, which I downloaded from GitHub. Did a pretty good job. Like Claude Code and that plugin, they did a better job than I could ever do. pretty sure of that, especially in the time it took. There's a little bit of animation here. You can see some animation on the top right. I didn't even ask for that, but that got put in. But there's another slide where there is some animation I did ask for. It's not bad. Like, it was done pretty quickly, and that would have taken me a long time to get right. But anyway, let's start talking about how an AI agent can be coded. Oh yeah, and since I'm talking about how the HTML slide deck was created, like I was saying, Claude Code created it and all the content. At least the first draft. I did review it and request changes in that. So you will see some AI isms in here. They get a little bit cute sometimes, but so like for this slide here, I didn't even ask for this slide, but it chucked it in here, so let's just cover it anyway. So what's an AI agent? I think everyone probably knows what an AI agent is by now, but it's not a chatbot. So a chatbot answers and an AI agent acts, and in this particular agent we're going to be talking about, or maybe all agents, there's three things that are glued together by a loop. So we've got an LLM. That's the AI itself. It decides what to do. In this case, for my Jira agent, the LLM that I'm using is Gemma 4. And there's some tools. So that's how we actually, get things done in the real world. And then there's a runtime that runs the tools that feeds the results back to the AI. That would be. And that's it. The rest is plumbing. So as I was saying, this AI agent is called Jira Agent. It's a tiny Python command line interface that drives a real Atlassian Cloud Jira instance from natural language. The whole thing is small enough to be read in 20 minutes. So we can see it running over here. It's all all Python. So UV run Jira Agent runs the agent. It pumps out a little bit of front matter, I guess, just telling you I'm up and ready. Agent's ready to go. Tells the user what the model is. Like I was saying, Gemma 4 31B is the one I'm using, running in Google AI Studio. And it just tells the user, okay, I'm ready to take requests, and if you want to quit, that's how you do it. So here's the prompt, and then this is an example of and an input that I would have given it when I was doing some testing. In this particular AI agent, it's always printing out what it's up to, which is, this was a learning project. I don't have heaps of experience, or any experience really, writing AI agents, and the whole point of doing this little project was to start learning. So it's telling it is telling us what's happening under the hood all the time, and then later on, this is the last summary that the AI returns to the agent, and that's the end of the turn, so to speak. So that request has been completed, hopefully successfully. So on this slide, we're looking at the components of the AI agent, and we can see a little bit of AI cuteness up here, dramatas persona. That's pronounced. I didn't ask for this stuff, but it's that's what you get from the AI sometimes. And so there is a color coding convention here, and this black bit down here, or dark navy blue, whatever it is, that's external. Components that are external to the agent, and all the bone colored boxes, they are part of the agent. So there's a command, and it's all written in Python. So there's command line interface, and it's telling us that that's in CLI.py. There's the agent itself. This is the heart of the project. It's pretty small. It's 40 lines. That actually seems really small. I don't know if it is that small. Actually, it might be like 60, but it is pretty damn small. Then there's an LLM client. This is a class. It's in LLM.py. It's a thin wrapper over the OpenAI SDK. We will talk about this a little bit more because you might be wondering to yourself, we're using Google Gemma 4, and how is this OpenAI SDK getting wrapped into this or being used? And we'll come back and cover that off in a bit. Then there's tools.py. So there's 5 tool schemas in this version of the AI agent. So 5 tool schemas for the LLM and a dispatch function that runs them. So like I was saying before, tools are how we get things done in the real world, or how in this case we're gonna instruct Jira to do whatever admin task we want to do. And then there's a Jira client. And this is another class. It's in Jira client.py. So it's a small HTTPX wrapper for the Jira REST version 3 API. Claude Code decided to use the REST API instead of MCP, and I think we're going to come back to that and explain that in a future slide. And then the external components, there's the LLM, so that's Gemma 4 in this case, running in Google AI Studio, and Jira Cloud. And I'm not going directly to Gemma 4. It's actually going through Open Router. So I think we'll talk about that in future slides as well. But just briefly, like when actually maybe I'll switch over to the prompt. So before I did any coding in Claude Code, I did a planning session in plain old Claude, and it eventually after I told it what I wanted, and it'd come up with the prompt that I gave to Claude Code, and we're looking at it here. And you can see, I think it actually says, Gemma 4 via Open Router. And, that was because, as part of the planning, I said, I might want to, because I've never used Gemma 4 before, and I wasn't too sure how capable it was. I'm always a little bit nervous or reluctant to not use Claude Code and Codex or OpenAI and Claude Anthropic, because they have really good products. I feel like I could be wasting my time to use some of this open weight stuff, but I want to give Gemma 4 a go. But I wasn't, like I was saying, I wasn't too confident Gemma 4 was actually going to be able to do anything well. So I said, well, maybe I want to, if it turns out to be a bit of a useless model, I might want to, try some other open weight ones. And that's where the Open Router requirement come from. So Open Router is it's as the name suggests, it will handle your requests and route them to whatever model you've chosen to route it to, and you tell it which model, and there's a whole bunch of models in Open Router. So I'm over an Open Router here, and we're actually just looking at Google, what the one I'm actually looking at. But if you come back, where's the models? There's a whole bunch of them in here. I'm not even sure how many. Looks like there's over 300. So there's a whole heap. I'm using Gemma 4 in particular, but that's why I used Open Router, just so it would give me the easiest option to get my agent, Jira agent, using another AI if I wanted to. And as it turns out, Gemma 4 is, for the simple tasks I've been asking it to do so far, it's actually worked pretty well. So I haven't actually used any other open weight models yet, but Open Router, I think you can go to Claude Code and OpenAI, but I've never done that. So this is an important slide, how the pieces are wired together. In this one here, we're going to trace through the execution path and the data path, and it's if you've never coded AI agents before, and if you're still watching this video, that's probably you. You might I was a little bit surprised how it worked, and there's a lot of communication going back and forth just to get one turn completed. So before I start stepping through the execution path, I'll just give a quick introduction. So these black text boxes, they're part of the agent. They're Python scripts that we wrote, me and Claude Code or Claude Code. And the blue ones, they're the external the external components. So Open Router we've talked about. This is this is Gemma 4 for the purposes of this video, and that's in Google AI Studio. And over here is Atlassian Cloud with Jira instances, and the arrows are pointing like how data will flow. So it's obviously okay. So you got your command line interface, and that talks to the agent. That's probably not too surprising, but the data flows in this stack over here, they only go vertically. They don't go horizontally. So the agent, when it talks to the model, there's only data going up and down this stack here. There's never any data going from left to right or right to left. So when the agent says, I want to get some decision from the AI, it talks down through the stack to the AI, and the AI comes back up to the agent, and then it's up to the agent. If there's something with the agent says, hey, go do something in Jira, it's up to the agent to go kick that off, and then it comes down this side here, and it tries to do whatever it does, and then it comes back up, and we'll talk to that in a bit more detail as I click through the animation. There's going to be a lot of transitions here. I think there's 23 transitions in all, so it might be a bit of a information dump or a brain dump, and that's okay, because in future slides we're going to come back and look at all these steps in more detail, and obviously in a lot slower. So before I start going through the animation, there's two things I should probably cover. The first one is, for the rest of this video, the concrete example we'll be seeing in all the slides is the natural language request to assign Scrum 6 to me. So that's something I would have typed into the CLI, and I wanted this ticket Scrum 6 to be assigned to me. So when I jump over to Jira, you can see this is Scrum 6 down here. That's the ticket. It's already assigned, because obviously I've done it already. And the second thing I want to say is this slide here in the animation. This was all done by Claude Code, and originally it didn't have an animation. It was just pretty much this document. This diagram was a static diagram, and I was going, I wouldn't mind actually seeing that as an animation. So occasionally you turn that into an animation, and it did. And I think it took 10 minutes to do it, or it might have been one of the longer turns it did. But for me to do this by hand, well, I would have been working on this for a whole week, or I don't know, like a couple of days or something. And it was done in 10 minutes. These AI agents, they pretty much every time I use them, they do blow my mind how good they are sometimes. Anyway, so let's trace our way through the execution path. Okay, so off we go. So the first step is the CLI reads assign Scrum 6 to me from the input. So it's it's something, a natural language that I type in, and then it hands that off to agent.chat. So agent is a class, and you can see there's a class up here, and chat is a method in that class, and there's a lot of chat methods in this agent. We'll see chat a few times. Don't get too confused. It's not always the same chat, but anyway, so it hands it off to the agent, and the agent calls llm.chat. So here's another one of the chats. It's passing in the messages, and it's passing in all the tools. So we'll cover this again, I'm sure, in the slides coming up. But this messages is the conversation history, and this tools is the manifest, or the list of all the tools that are available to the agent to get stuff done. So every time, and this is this wasn't immediately apparent to me when I first started using AI. Every time we talk to the AI, you send the conversation history in full with all the tools every single time. And the AI, it doesn't have any memory. It's a stateless, it's a stateless function, basically. That's the way I look at it. Hopefully that's pretty good abstraction. And it's rereading the whole conversation history every time again to learn, okay, what's the context of what this guy's telling me to do? So when we're saying assign Scrum 6 to me, it's sometimes it's going to need some context from the previous, the conversation history to know what I'm talking about sometimes. And it doesn't have a clue what tools what tools are available. We have to tell it every single time, what tools are available to it. So if you sit here and talk to a CLI, you have a conversation that goes on for like hours and hours and hours. This is getting bigger and bigger and bigger. And it's filling up the context window. Probably a little bit. Like the context windows are pretty big, especially for Claude and OpenAI. I think I saw it's like 1 million tokens for Claude at least at the moment. But anyway, so that's what agent does. So agent, passes off the conversation history. And at the moment, the conversation history is one thing. Assigned Scrum 6 to me and the tools, and then LLM client. It uses, over the OpenAI SDK, it sends that request to OpenRouter, and so OpenRouter understands OpenAI SDK, and that's why OpenAI SDK is getting involved here, even though we're actually talking to a Google model. That's because what OpenRouter understands, and it's pretty. I think it's it's a bit of a standard. But OpenRouter itself, it must be doing a translation from OpenAI's SDK to Google's SDK, whatever that's called. Yep. So anyway, we're in OpenRouter, and it's got our request, and then OpenRouter relays the message to the upstream LLM, Gemma in this case, and this is the model deciding what to do, and it in this case it's deciding to emit a tool call. This is an interesting bit, and maybe it's obvious to some people, maybe not obvious to others. You could be forgiven for believing the next step is going to be a jump over to Atlassian Cloud to get something done, but that's obviously not. That's not what's going to happen. The AI can't do anything, really. It can make decisions, it can tell the agent what to do, but it doesn't actually do anything in Jira itself. And we're going to see that. So the next step is the model returns assign issue. So, in this particular case, it's saying call this tool assign issue because it knows we told it what all the tools available to it is. Oh, and it's got a system prompt too, by the way. So this agent's got a system prompt. As part of that message is, the conversation history that gets sent. The first thing in it is a system prompt. And that system prompt, it says, I think it's the first sentence, says you're a Jira, Atlassian Jira assistant, helping this guy, this Jira numpty, how to do Jira admin. Anyway, so the AI is it says, okay, I want you to do a tool call, and you is the agent. The issue key Scrum 6, we told it we wanted some Scrum 6, that's where I got that from, and the assignee is me. That we'll come back to how we resolve this me, in Jira later on, and then it starts going back up the vertical path back into the agent. So just to reiterate, it's not telling Atlassian Jira to do anything at all. It's telling the agent what to do, and the agent's going to have to talk to Jira. So we're back in OpenRouter. It just gets passed straight back onto the LLM client. And then the LLM client hands the path reply back to the agent. So now we are back up at the agent, and the agent sees that it's a tool call, and it goes, "Oh, I got a tool call. It's time to dispatch the tool call." And this is another thing I'm sure we'll talk about, in future slides. But the way the agent knows that the original request we put in has been satisfied, is the AI will return a reply that has no tool calls. It's just plain text. And when the agent sees a plain text reply, no tool calls, then it sends that back as the summary. It goes, "Oh, we must be done," and it sends that back to the summary to be displayed to the user. But anyway, there's a tool call on this one, so we're not done. So it's in this agent it's called dispatching. So let's move on. So now we're moving down the right hand path to get some stuff done in Jira. And so the dispatch is done via tools.py. Looks up the handler in handlers. So this is where we map the tool call, the decision, what the AI said, okay, I want you to use this tool. We map that name to some actual Python code to do the assign. And that's happening now. And then so the handler call is Jira, assign issue. So Jira, there's this Jira here. That's just an instantiation of a Jira client. Jira client's a class, and assign issue is one of the methods in Jira client. And it's actually, okay, now we're going to start telling Jira what to do. So the first thing that happens is, so Jira client hits the Atlassian Cloud, like it sends over the REST API a get myself. So this is the me bit. So you might remember, up in the original request we said assign Scrum 6 ticket Scrum Scrum 6 to me. Well, who's me? And this is us figuring that out. Sorry, the agent, I should say. This is the agent figuring that out, and we're going to get an account ID back. So that this is really this is a two-step process, and this is coding inside the agent. Like you don't get me for free from Jira, so that's what we have to do. This get myself and get an account ID back, and then once we've got an account ID, then we can actually get a ticket assigned to this account ID, and so that's the second step. So there's really a two-step process talking to Jira here. Get an account ID and then actually do the assignment. And so that gets sent off to Jira, and Jira returns a 204 no content. I think that's a good thing. Actually, I do forget what that is. I think that's like, yeah, okay, there's no errors. And that is it. What it is actually. So the Jira client. So we're back up in the agent now. So the Jira client returns the result to tools.py. Tools.py wraps it in an OK. So it's saying, yep, that tool went OK. Well, it's OK is true. And look, there's some other data in there as well. But it's just the Claude Code just put ... in here for brevity. And now we're back up in the agent. So the agent appends the tool result. So this is what we got back from Atlassian Cloud, transformed up in tools.py. So it puts that into the history. That's the conversation history. And then we're back at step one. And so we want to tell the AI what happened. So the AI, because the AI might want to, maybe something went wrong, and maybe the AI can recover from that. But so the next step is not to the command line interface. That's maybe another assumption people might make. Okay, it's successfully done. Well, the AI doesn't have a clue it's been successfully completed. So we send the result of the tool call back down to the AI, and that's what's happening now. So LLM client, it calls chat again, and it's, with this success envelope in the context. So that's because that's the conversation history. We've just appended this return data from. It goes back through OpenRouter, and it goes back into the AI, and now the AI goes, oh, okay, that was successful. Well, that's it, we're done. The assign, what the user asked for has been successfully completed, and it replies with plain text. And as we spoke about earlier, plain text, that's going to tell the agent, oh, we are done to turn. The request has been completed successfully. So and then the AI, sends its plain text response back. It comes back through OpenAI router. We land back in LLM client. So this will be the chat call. It's a synchronous call, like it's blocking on listening to the AI. Anyway, so that's returned, and the plain text message we got back from the AI is assign Scrum 6 to you. It's great. It's changed the pronoun, I think, from me to you. So it's telling us what's happened, and we're back up in the agent. So the AI agent goes, so the agent says, okay, well, there's no tool calls in this reply. That's it, we're done. So it returns the text to the command line interface, and the command line interface prints the reply to the screen, and the turn is complete. So that is the full execution path for that one assign Scrum 6 ticket to me. There's a fair bit going on there, and we're gonna trace through all that again, in a little bit slower in the upcoming slides. So hopefully that gives you a mental map of how the execution path flows. So when we start digging into a little bit more detail in the upcoming slides, you've got a map in your head of where we are in the data path or the execution path for that request. So on this slide here, we going to cover very briefly what we've pretty much just covered in 10 minutes in the last slide. But so it's saying here 1 turn in 4 steps. So step 1 is ask the model. So we send the whole conversation history plus the available tool schemas to the model. Step 2 is read its reply. So you read the models, the AI's reply. If it's plain text, print it, so to the screen, and the turn's done. If it's not just plain text and there's a tool call in there, well, we keep going and we go to step 3. And step 3 is we run the tool. So we dispatch to a Python function, hit Jira, and capture the result. And then step 4 is loop back. So we append the result to the history. That's the conversation history, the context, and we go back to step 1, where we'll send it back down to the model so it knows what's going on, or it can do whatever it decides it needs to do. There is a cap in this application on at 6 iterations. That's just a guardrail, so the AI can't get trapped in a never-ending loop trying to fix something it can't figure out how to fix. And that's a high-level summary again. Maybe this slide's actually a little bit redundant, but anyway. So the next 10 slides, the same loop, and we've just slowed it down quite a bit. So this is the bit where we start digging into a little bit more detail. Let's look at the command line interface in a little bit more detail. This is where the words come in. You can see the code over here on the right. It's just a basic while loop with an input to read in the user input. The read line has been patched in, so you can use the up and arrow keys to go up and down the command history. You can use Control R to do a reverse search. The CLI, the command line interface, it doesn't know anything about LLMs or Jira. It just gives whatever the user types in, just hands that straight off to the agent via the agent classes chat method, and then it just waits, and whatever's returned by this chat is what it prints on the screen. Except, this is worth noting here as well, since this is a learning project, there is a trace of the tool calls, happening under the hood, so to speak, and this is handled via a callback. So agent.chat, it never prints itself. It only does stuff, and it leaves it printing to the CLI. So the CLI passes a callback. It's called onToolCall, and it passes that to the agent, and the agent invokes it after every tool result. So that's where the trace lines come from. That's about all there is to say about the command line interface. It's pretty simple. So next we move on to the agent loop. This is the heart of it all. In the code's over here on the right again, or at least an excerpt of the code. So every chat turn drives this loop. It runs until the model produces a plain text reply, or it hits the safety bound at 6 iterations. The conversation history lives in the agent instance. So that's how multi-turn references such as add a comment to that bug. You can say that, and the AI will figure it out from the command. From the conversation history. You can see here's the text over here on the right. So every loop iteration, it kind of goes through four steps. So it asks the LLM what to do. Depending on what we get back from the LLM, it branches. And then if we've got a tool call, it'll dispatch the tool call, and then whatever comes back from that tool call, it gets appended to the conversation history. So we can see, you can see that up in the code. So here's the max iterations of 6 guardrail in practice. Here's where we call the LLM. So there's another one of those chat methods, and this will block. So it's just going to sit here and wait till we get a response back from the AI, and it'll append the response to the conversation history. It's underscore messages in this case, and then it'll look at the response, and so it'll say if the response doesn't have a tool call, well, it's plain text, we're done. So it returns the response back up into the command line interface, or alternatively, we must have a tool call or tool calls. It's possible to get multiple tool calls requested by the AI. It'll iterate through the tool calls. It probably will just be one, and dispatch those tool calls. And we'll have a look at this dispatch in a little more detail in an upcoming slide. And the result is then appended to the conversation history again as well. On this slide, we'll talk about the large language model client. The point of this class, because you can see it's a class over here, is to abstract away the code that talks to the model or the AI. So you might remember there's LLM client .chat calls. That's agent.py, or the agent class will call this chat, and it will pass in the conversation history and any tools, and that's all the agent needs to know. And it's down in this method is where the implementation of the nuts and bolts of actually talking to the model or the AI. Now in this case, the way LLM client .chat's coded at the moment, it assumes that whoever it's talking to, and that is configurable, OpenRouter is the default, whoever it's talking to understands the OpenAI Python SDK or the OpenAI API. If you wanted to talk to an endpoint, such as go directly to Google Studio, Google AI Studio, Gemma 4, and skip OpenRouter altogether, you would have to recode or add some new code that would talk that API, because at the moment it's just talking the OpenAI API. So that's the point of LLM client. You can see it's got a little note down here. Claude Code's got a little note saying OpenAI compatible is the lingua franca of tool calling. So OpenRouter understands it. Llama, Together, Grok. I guess they all understand as well. I've actually never used those, but that must be the case. And if you do want to change your provider, so you don't want to use OpenRouter, the way you would do that is you would change the configuration via a .env file. And here's an extract of the .env file. The way it's defaulted to, the base URL for the LLM is OpenRouter, and you specify the model as well, and we're specifying Gemma 431B. So we've sent our message to the AI, to the LLM, and it's made its decision about what to do. And now, so that's the bottom left-hand side of that parallel vertical stack. So we're down, we hit the AI, now we're considering how the model's reply is going to come back to agent, to the agent class, agent.py. So it'll come back up through OpenRouter, through LLM client, and back into the agent. And the model's reply can come back in one or two ways. As we've already talked about this, it can come back as plain text. And if it comes back as plain text, just to reiterate, the model is satisfied that it has all the information it needs to answer, and the agent prints the text and returns. And that's the turnover. I think that's the request completed. Here's an example here. Created Scrum 6, so created a new ticket, and no tool calls. Or, the other way, the outcome B is the model has actually asked or requested or decided we need to do a tool call or tool calls. So this is, the model needs to act before it can answer. Send back this plain text. So tool calls arrives as a list, and the agent runs each one of these and feeds the results back to the artificial intelligence. So here's the response. The content's none, and the tool calls is not none. Like, it's actually got some tool calls in it. And you can see in this example, the tool call function name is assign issue. So the AI has decided it wants the assign issue tool to be run, and the arguments is the issue key is Scrum 6. So ticket Scrum 6, and it needs to be assigned to me. So the AI has made its decision, and it's telling the agent, the agent class agent.py, okay, this is what I want you to go kick off this assign issue tool call. Now we'll talk about actually using tools. There's in tools.py, there's two halves. This is Claude Code's one of its cute blurbs. Two halves, one purpose. So the two halves is talking about is the tool schema and the dispatch function or the dispatch method. So tool schema, this is where we list, okay, what tools are available that do we implement, does the agent implement that the artificial intelligence can use. So we don't pass functions obviously to the AI. We're just passing like a manifest of the tools we've got. That's how I think about it. And the manifest says, okay, these are the tools, and there's a tool name, and here's the description of what these tools can do, and it'll also tell it what parameters are required to the AI is going to have to provide so the tool can be fully executed. Over on the code block on the right, this tool schema isn't included in this code block. It's just the dispatch function. So there's no example of the tool schema on this slide at least. But it does have the dispatch function. So the dispatch function runs the tool, and it's saying here, the dispatch function catches every exception, so the chat history never ends up with an orphan tool call. Just on a little tangent. When Claude Code originally wrote the AI agent, it didn't catch everything. Like, it wasn't catching all the exceptions that were possible. I think it was just catching this Jira one from memory. I actually forget. But eventually I got Codex, OpenAI Codex, to review the agent once Claude Code and I had coded it, or Claude Code had coded it, and I tested it under Claude Code's direction. Then I got Codex to review it, and this is one of the issues that Codex picked up. It said, you're not catching all these exceptions, so you might end up with a out of whack chat history. So yeah, I've had quite a bit of, I quite like using Claude Code and Codex together. I pay for the $20 US version, $20 US versions of each. And if I use Claude Code to implement a project like I have with this one, I'll get Codex now to review it, either in GitHub if I've got it in GitHub, or I'll just do it locally. It's their reviewing is pretty good. Like, they generally find some good stuff that I probably miss definitely. But anyway, so getting back to the actual slide pack. So let's go have a look at dispatch. So handlers, this is where we map the name of the tool that the AI that Gemma 4 has said, okay, I want you to run this tool. This is where we map that name to an actual function that gets called, and you can see that, and that's what's happening here. And later on, we'll actually call that handler down through the Jira agent, with the arguments that tool call needs, and then we just sit around waiting for the response, basically. And that's tools.py. This is where we make the connection between the manifest, the tool schema, the name in particular from a tool schema for a tool, and where it actually, the code that actually gets run when the AI tells us to run one of these tools that it knows about via the tool schema that we send every turn. Oh yeah, by the way, this bit of text down the bottom here. So it's saying there's 5 handlers. These are the 5 tools that the agent implements. So we've got Python code that actually implements these 5 tools, and that's all the tools that we tell Gemma 4 about. And this is the 5 tools it's got to choose from to do stuff in Jira. So at the moment, there's a create tool, so you can create a ticket. There's a search, so you can search for tickets, just using JQL, the Jira query language. You can transition tickets through the states, some in progress to done or whatever. You can comment on a ticket, and you can assign a ticket to a user. So if you want to do more things in Jira that you can't do with these tools, that would be up to us up to the agent developer to add new tools, and then add them to the manifest, so the AI knows there's some new tools it can use to interact with Jira. So we're working our way down the right-hand side of those parallel vertical columns, and we're down into the Jira client. This is the class that starts talking Atlassian, starts talking Jira. You can see we're going to be making REST API calls. I'm not going to run through this text over here on the left that Claude Code come up with. I don't think it's particularly helpful, but there is, we'll talk about this bit here. So it's the explanation of why why Claude Code decided to use REST and not MCP, and the reasoning is MCP just complicates things a little bit. In a production system, maybe you probably would want to do that, but this was specifically a learning project, so it's gone with REST API. So just to keep things simple. So the text block here on the right hand side, it's not the full Jira client class. It's one of the functions, or one of the methods within. It's called a sign issue, and the reason Claude Code added this to the slide deck. That's what we're doing in our concrete example. We're assigning a ticket to ourselves. So we can see up here this whole first block of code. If else. We're trying to find out the account ID we're assigning the ticket to. And you may remember from earlier on, this actual query said assign Scrum 6 to me. I think it was Scrum 6. And like me, who's me? We've got to figure out who me is. And this is where the Jira agent itself, the agent itself is got to figure out, okay, well, it's got some smarts to say, okay, well, the user wants to assign a ticket to themselves, to me. So I'm just going to query Jira who myself is, and I'll get that's how I'll get my account ID. But there's other smarts in here as well. So you might want to unassign a ticket, and the agent will handle that for you as well. So it'll trigger on if the user put an unassigned or none. It'll set the account ID to none. But if it's not one of these cases, well, we've got to get an account ID. And so what the agent is going to do is it's going to request the account ID for the assignee that's being passed in. So someone's name, or a user account's name. And if that's found, that's where the account ID is. So so we got the account ID. So that's step one. We've already spoken to Jira, like up here, unless it's none, and we got our account ID. And our step two is to actually assign the ticket to this newly found account ID, and that's what we do down here. So it's for another REST API call. So we've hit Jira with the API calls, and Jira's responded, and now we flow that message, those responses back up the right hand side of that parallel vertical stack you might remember from one of the earlier slides, and we're now closing the loop. So the response from Jira eventually gets back up into the agent, agent.py, into the agent class, and we will now append that to the conversation history, and then that whole conversation history plus all the tools, in the system prompt, blah blah blah, it's all in the conversation history, and that gets sent back down to the large language model. And this is going to give the large language model a chance to see what happened when it's the tools calls it decided needed to happen hit Jira. And in this case, it's probably going to say, oh, that tool call did the assignment in Jira, and it's job done. So it'll reply. The large language model will reply with a plain text response, and that'll go back up the left hand side of that vertical stack into agent.py, and the agent class, and the agent class says, oh, I've got a plain text response. We're done, and it sends it back to that plain text response from the artificial intelligence back to the command line interface. The command line interface prints it to the screen, turn over. That's the whole loop completed. It's got some text down here about the max iterations of 6. As that guardrail. We've spoken about that, so I won't hit that one again. Over here on the right, it's not so much. We haven't got any code, but I've got the conversation history after one turn. So this is what a conversation history is going to look like, or at least the part of it. Don't forget, the conversation history have the system prompt, and when the conversation history is sent to the large language model, it's always going to have all the tools included in there. But anyway, I'll try and read through this. I'm not super familiar with this, how this conversation history works. But up the top, so we got a system. This must be the system. This could be the system prompt up here. And then there's the role user, and we're sending down to the LLM assign Scrum 6, the ticket Scrum 6 to me. So the next part that was appended to the history is the first LLM call emits a tool call with an ID. So this is what's come back from the large language model. It says, okay, I want you to do a tool call, and this tool call is going to be identified as call A1, and we'll see call A1 down here again. And it's an assigned issue, and Claude Code's just chopped out a bunch of stuff here just for brevity. Where you see these dots, it's just keeping things concise so it all fits on a page. anyway, so the large language model says, hey, I want you to do a sign issue tool call, and the next message that's appended to the conversation history is a tool reply, and it must echo that ID back. So here's the connection between the tool, the large language model saying, hey, this is the sign issue tool call, and here's the response to it. So that that's how the LLM knows. I think that's how it's making the connection between those two. So it knows this. Geez, I'm kind of butchering this a little bit. It knows this is a response to this. And then the second LLM call is the plain text. So then we've sent the tool call response down to the LLM, and it said, oh, it worked. Okay, that's great. And then the LLM responds with it's plain text message, and that's the end of the turn. This slide covers a couple of things we've already covered, but they are worth mentioning again. I won't do number one, the standard wire format, very very deeply. This is the bit where it's we're just assuming we're going to be talking to an endpoint open router in our case that understands the OpenAI API. That's the science decision we made, and that makes the whole point of doing that is ostensibly the LLM is just a swappable part, and it's swappable via a small change in the .env file. That's not totally true. If we're going to go straight to Google AI Studio to talk to Gemma 4, I don't think that's going to understand OpenAI's API, but maybe I'm wrong. But the one on the right is worth covering again. So the large language model only ever describes what it wants to be done. It never executes anything itself. So this is, you might remember way back, I was saying in those two vertical stacks, parallel stacks, data and execution flow will only go vertically up and down. It will never go horizontally. So the large language model is never going to do anything directly with Jira. So, the AI is just going to make a decision about what it wants to be done, and what tools it wants to be called, and then it tells the agent to do that. So that's this bit here, the runtime executes. And then we once the agent's executed that tool call, then we give the result back to the LLM, so the LLM can decide what it wants to do next. Everything an agent can do is what its tools allow. Wants a new capability, add a tool. Wants a sharper safety boundary, remove one. The blast radius lives in tools.py. So this is Claude Code telling us, basically you got 5 tools in the current version. If you want some more capability, you have to add a new tool. If you want some guardrails, you want more safety, you have to code it in the AI agent. So speaking of safety, speaking of guardrails, there are some in this learning project, in this simple AI agent. It's not comprehensive, that's for sure. And you might remember earlier on I was talking about using Codex to review Claude Code's implementation. Well, there was some of Codex's, maybe it was just one, maybe a couple of the review comments from Codex were around safety and guardrails. I was of the opinion this is only a learning project and it's definitely not meant for production, so we don't have to get too comprehensive. But there's definitely some guardrails in there beyond that iteration, the max iteration of 6 turns. So I might just try and run through these. So dispatch is total. So every exception is called wrapped. So that was one of the, we did mention that before. That was one of the Codex review comments. Is like, you're not catching everything that you could catch. Untrusted Jira data is delimited. So free text fields from search results, they're wrapped in trusted tags before the model sees them. And the system prompt, we send in that's part of the conversation history. It's right up the top. It tells the model, when you see these untrusted tags, that's just data. It's never to be interpreted as instructions. So I guess this is a form of prompt injection defense. What else have we got down here? So friendly errors enable self-correction. So wrong transition name produces an error that lists the valid options. A strong model reads and retries with the right one, turning a 400 into a recovery opportunity. Right. So I think what it's saying here is, catch the errors, or recognize the errors and pass them back onto the LLM, so the LLM can decide maybe there's some recovery I can do. One thing we didn't do in this learning project, the version 1 it's being called here, is write confirmation. So I'm sure if you've used Claude Code or Codex, a lot of the time it's going to ask you to confirm to do stuff. This agent never asked you to confirm to do things. That's okay, because it's just a tiny little learning project. But if this was to evolve into a production agent would be released into the wild, you definitely want to start putting in write confirmation. At the end of the presentation, I won't run through this slide. It's just a bit of a summary of what we've talked about probably multiple times already. I think when I was creating the agent with Claude Code, I can't remember exactly, I wasn't keeping track, but I think it probably took about 4 hours to do the planning, and then with Claude Code create, implement the code, and then do some testing. And then that was probably maybe 4 hours, give or take. And then I probably spent a couple of hours working through, or maybe a couple of hours, maybe one, maybe two, working through the Codex review, or getting Codex to review the code in the first place. And that was really quick. I think it was like a minute or a minute 20 or something. But then actually work through the 8 or 9 comments it had, and to get Claude Code to fix them up mainly. So it's probably like 6 hours. So we probably got the version, the last, the MVP, the version 1 of this little learning tool was probably coded up and tested and reviewed in 6 hours. It's not a huge amount of code. It is pretty small, as this slide deck mentions a few times. But if you were to plop me down in front of a terminal without any AI assistant, without Claude Code, and say, hey, all right, you go code this up, I don't even know if I could do it. I'd be, with a bit of Jira searching, if I had a Google search, I'm sure I could, but I don't think I'd be doing it in 6 hours. Probably take me a few days, and this is the first time I've ever done this. So, if I had done this like just myself, just using Google search, I don't know, I probably would have spent a whole week or 40-hour week probably getting this thing up and running. Oh, yeah, maybe. So anyway, look, it was pretty quick. It was a very, very good learning experience working with Claude Code and to a much lesser extent Codex. Yes, that's it. Thanks if you got all the way through. I think I ended up recording about an hour's worth of talking. Hopefully it wasn't too boring, and it was informative or educational. So yeah, I'll see you in the next video.